enormous quantities of CO2 and these other gases into the atmosphere every year with hardly any concern about its
The isolated
multiplication.
cake lives on for hours and reacts to external stimuli.
Welcome aboard, aboard, aboard.
Welcome aboard, Earthlings and fellow space enthusiasts. Prepare for the interstellar journey into the realms of fluid dynamics as we embark on a mission led by our esteemed space commander. Today, we delve in the cosmic wonders of steady and unsteady flow, drawing parallels between the celestial dance of stars and dynamic forces shaping the very essence of our terrestrial existence. Guiding us through the celestial odyssey is none other than the seasoned space commander, whose expertise transcends to the boundaries of Earth's atmosphere. Our interpreted crew member, Patrick, the cosmic cartography, John, the propulsion pioneer, Mark, the stellar engineer, then the astro practitioner, and James, the astronaut philosopher, contemplating the cosmic ballet.
Steady and unsteady flow. A steady flow is one in which the condition, velocity, pressure, and cross-section may differ from point to point but do not change with time. Unsteady flow, if at any point in the fluid the condition change with time, the flow is described as an unsteady. If the flow velocity at a given point does not change with respect to time, then the flow is called steady flow. However, if the velocity at the given location changes with respect to time, then the flow is called unsteady flow. And that's a difference between steady and unsteady flow.
Nature of steady flow. Constant and unchanging. Steady flow is characterized by the constancy of fluid properties at a specific point within the flow. These properties such as velocity, pressure, and temperature do not change with time. Equilibrium. In steady flow, the fluid is in state of equilibrium at any given point. This means that the force and acceleration acting on the fluid are balanced, resulting in a constant and predictable flow. Time independent. Steady flow is time independent, meaning that the fluid behavior remains the same at the point over time. It allows for simplified mathematical analysis and is often used in engineering calculations. Common in steady systems. Steady flow typically assumed in scenarios where the flow conditions do not change significantly, such as in most steady-state industrial process and continuous fluid transport in pipelines. Nature of an unsteady flow. Time-dependent. Unsteady flows involves variations with respect time and specific point. Fluid properties change over time, leading to dynamic and transient behavior. Non-equilibrium. In unsteady flow, the fluid is not in a state of equilibrium at all times. There can be unbalanced force and accelerations, leading to fluctuations in flow properties. Transient event. Unsteady flow is common in scenarios with sudden changes or transient events such as water hammer in pipelines, uncontrolled release of fluid, or rapidly changing flow conditions. Complex analysis. Analyzing unsteady flow requires considering the time-dependent behavior of the fluid and often involves solving partial differential equations. It can be more complex than steady flow analysis.
Unsteady flow or transient flow is when fluid properties change with time and location. These are the 5 practical applications of unsteady flow. Unsteady flow is vital for hydroelectric power plants. Understanding it helps optimize power generation. Unsteady flow analysis is crucial in traffic engineering for real-time traffic flow, modeling and management, signal timing, congestion control, and predicting traffic patterns during events or accidents. Unsteady flow in environmental models stimulate pollutants movement in rivers and oceans, aiding environmental assessment and remediation strategies. Unsteady flow is crucial for understanding the aerodynamics of aircraft and spacecraft during takeoff, landing, and turbulent air encounters. Unsteady flow analysis is crucial in chemical processes to study transient behavior for optimization and safety. Unsteady flow modeling is crucial for efficiency, safety, and environmental impact assessment in various fields.